All right, welcome back to the last lesson in Unit 5. We are going to be looking at the restrictions on composite functions. So I think I told you last time that when we look for the domain for the composite function, you also need to take the original functions into consideration, okay? Not just the final part, not just the final composite function. So that's what we're going to be doing today, and we're also going to graph, okay? So let's look at the first example here. It says use the function f of x as 2x plus 1 and g of x as x squared minus 4. We're going to sketch the graph for g of f and also state the domain and range of g of f. Okay, so first of all, let's figure out what g of f is. G of f of x. So remember, this is the same as this, but I like to write this notation better because it kind of makes more sense to me. Okay, so we're going to put f function into g. So f function is 2x plus 1. We're going to put into g function. So I see x squared. So right away, I'm going to put 2x plus 1 squared and then minus 4. So you should get 4x squared plus 4x minus 4. Let me just double check. Oh, I forgot one thing. Plus 1 and then minus 4. So this is going to be 4x squared plus 4x minus 3. Okay, so this is a quadratic function. So the domain is going to be all real numbers, no problem. Range, we can find the vertex. Okay, so the vertex, recall, we can find the x-coordinate by taking negative b, negative 4 over 2 times 4, which is negative 1/2. For the y value, you simply plug in negative 1/2 into x, and the y value that you get is the y value for the vertex, and I believe it is negative 4. Okay, I worked it out earlier. Okay, so your vertex is going to be at negative 1/2, comma negative 4. This is a parabola opened up because the leading coefficient is positive. Therefore, we have a minimum. So the range is going to be y is greater than equal to negative 4. So I'm going to plot my vertex right first. Here's my vertex. This actually could be factored. Okay, so you can factor this, and if you factor that, you should get 2x plus 3 and minus 1. So your x-intercepts would be 0.5 and negative 1.5. You can also find the y-intercept quite easily by simply plugging 0 into x. Okay, and because this is symmetrical, so if you have a point there, you should have a point here. So this is your parabola right here. Okay, hopefully not too difficult. Okay, you just need to get the composite function and find the vertex because this is a parabola. And again, because both f and g are functions where the domains are all real numbers, we don't really need to worry too much about the domain for the composite function. Okay, so I'll let you try this one here, actually these two here, and see how you do. Okay, good luck. All right, for these two graphs, for f of g, again, here is your f of g. You're simply putting the g function into f, so I have 5 minus x squared, and that was substituted into the x minus 1 there, so the x is 5 minus x squared, and then minus 1 outside, so at the end you should get negative x squared plus 4. This time, I can actually find the vertex quite easily, again, because there's no bx term, so c value is just going to be the vertex, okay? So 4, right there, that's the y-intercept, and that is going to be the vertex. Because this graph is opening downwards, so that's our maximum, and I know that because it's negative x squared, and I can find x-intercept quite easily. If I put in 2 into x, I get negative 4 plus 4, which is 0, and if I put negative 2 into x, that's negative of negative 2 squared, which is negative 4 again, plus 4, and that's also 0. So this one is actually quite easy. Okay, but again, if you're not sure, you can always find the x-coordinate of the vertex by plug in negative b over 2a. And I mean, you can see this is going to be negative 0 divided by 2 times negative 1, which is 0. And that's why you can see the vertex has a coordinate of 0. If you plug in 0 into x, you get 4. So that's your vertex. Okay, so that's part A. For part B, f of f, so what you do is the same thing. You put f of x into the function itself. So you get x minus 1 and then minus 1. So you get x minus 2. This is simply a linear function. Therefore, domain and range will be all real numbers, right? And then it's a line, so that's easy to graph. Y-intercept is -2. The slope is 1, so you go 1 up, 1 right, 1 up, 1 right, and so on. So there's your line right there. Okay, so hopefully that's not too difficult for you. Example number 2, let's see here. It says, given the functions f of x and g of x, determine the explicit equation for each composite function below, and then state its domain. So notice I'm not asking for range because it's going to be trickier to find a range. Again, you can always use calculus to find the range in this case, but we're not going to worry too much about it since we're not there yet. Okay, so first of all, notice how this time f of x has a restriction on its domain, right? We know that x cannot equal to -2. Okay, so just keep that in mind. Okay. Okay, so now we can find g of f. We are putting f into g, so that means I am gonna put, anytime I see x, I'm gonna put f. So I have 1 over x plus 2 squared plus 3 times 1 over x plus 2. Okay, so this is going to be 1 over x plus 2 squared plus 3 times x plus 2. Now, we have fractions, so we can add them by having a common denominator. And recall, if we want a common denominator, in that case, then I just need to multiply the second fraction by x plus 2 as well. If I multiply this by x plus 2 over x plus 2, then I will end up with 3x. This is going to be plus 6, and then plus 1, so plus 7 over x plus 2 squared. Okay, so that's my g of f. In this case, domain, so you can see again, for the domain, x will not be able to equal to -2, or should not equal to -2. Otherwise, you end up with a 0 in the denominator, and you can't do that, okay? Because you can't divide it by 0, okay? F of g, so now in this case, we're going to put g function into f. So this is going to be 1 over, and I see x, I'm going to put g function instead, plus 2. So you can actually factor this. This is going to be x plus 2 times x plus 1. Okay, so then you can see the domain x will not or cannot equal to -1 or -2. Because again, otherwise your denominator will be 0. We cannot divide it by 0. So recall, we'll end up with the asymptotes, vertical asymptotes on the graph. So I might ask you to graph it. I mean, it's not something that you don't know how, right? We did this in the previous unit. Same thing with 2a, right? You know how to graph this actually, or at least a quick sketch of it, right? You can find the asymptotes, you can find the x-intercept and y-intercept, okay? So, you know, you can actually do something about it. Not entirely don't know how to graph it, right? All right. Example number 3, why don't you try these two? Okay, because it's somewhat similar. It's obviously a little bit different because this time we end up with a root x function. But why don't you give it a try and see how that goes, okay? Good luck. Okay, so I'm assuming you're finished. Let's see here, g of f. We are putting f function into g, so this is going to be negative x squared. So instead of x squared, it's going to be root x squared plus 2 times root x. This is going to be negative x plus 2 root x. So domain, if you just look at this, it's actually the same as this one because you end up with a root x term. So x would have to be bigger than or equal to 0, so not a problem. Okay. For part B, we're looking for f of g, so you're putting g function into f function. So this is going to equal to the square root of negative x squared plus 2x. Okay, so now this one is slightly trickier. Okay, so notice how we want to, or we have to, we can only square root positive values or 0. So what we want to do is, since this is a quadratic function, what I'm going to do is I'm actually going to factor this a little bit. Okay, so I can do a quick sketch of this graph. So I know my x-intercept will be at 0 and at 2. And I don't really need to find out what my vertex is going to be. You could find out if you wanted to, that's fine. But you don't have to because we really just want to look at its shape. it's going to open downwards because it's negative x squared, right? So the leading coefficient is negative, so it's opening downwards. Now recall, this function is inside the square root function, and we can only square root positive or 0 values, right? So really, the domain would be in between these two, or in this piece, right? It's the part that is above or on the x-axis. So the domain in this case will go from 0 to 2, right? That's where our x-intercepts are, right? 0 and 2. So anything in between, you can see this parabola is positive, in which we can actually take the square root. But this piece and that piece, they are negatives, and we can't square root those values. And that's why this is our domain. Okay? Hopefully that was not too difficult for you to understand or to grasp the idea. Okay? Here is our last example for this unit. Okay, so it says for each function, determine possible functions f and g, so that y is going to equal to f of g. So we're going backwards, right? So here's the composite function basically, and we need to figure out f and g so that f of g becomes this. So notice g is the inside function and f is the outside function. Okay, so what you need to do is you need to think about what is the overall structure, right? Because that's the outside function. So the overall structure is actually 1 over x. Right? It's 1 over something. So that's the overall structure. And the inside function is going to be x plus 1. Right? So if you put this in here, you get that. Right? So that's the overall structure, 1 over x. G of x, that's the detail, I suppose. That's the inside function. Okay? Same thing with part B. You can see the overall structure is f of x, which is going to be x cubed, right? That's the overall structure, is something cubed. And the inside function, I mean, this one's easy to tell because it's inside the bracket, right? So that's easy to tell. The inside function is 2x cubed plus 1. Okay, so if you put this inside that, you get this. Okay, good. Easy, not too difficult, I hope. Here's the last 2 practice questions for you to do. Hopefully you'll get them quite easily. Okay, good luck. All right, assuming you're finished. This one, the overall structure is x to the power 4. The inside function, g of x, should be x plus 2. Okay, for part B, same thing. The overall structure is square root of x, right? Square root function. And whatever that's inside is your g of x, which is 13 minus x. And that's it. That's the end of this unit. As I probably mentioned to you, this unit is not the most difficult one. So hopefully you will do well. But again, if you have any questions, do let me know. Okay, good luck with your practice questions. See ya.